Hi everyone, welcome back to our YouTube channel Zero Analyst. This is the day 23 of our 30 days Python series. Today we're going to do a complete EDA projects on a new dataset, which is Airbnb listing datasets. So you're going to learn how to do a data cleaning, you're going to learn how to do a data explorations, you're going to learn EDA, you're going to learn data visualizations. So all these topics that is going to be included in this project. In this project, you will be analyzing 20,000 plus Airbnb listing datasets, which you can download from the video descriptions. So first, let me open the VS Code, which you can see it here. So I have already created the workspace, and this dataset name is called New York listing, which you can get it from the video descriptions. So let me first show you this datasets. This is the dataset that you can see. So we have ID, name, host ID. Let me just open it in Excel first of all. So let's go ahead and open it in Excel. So here you can see the datasets that we are going to explore, and this dataset has a 20,000 plus rows. You can see 20,771 rows of data we have, and the columns, if you see, we have ID, names, host ID, host names, neighborhood, latitude, longitude, room type, price, minimum nights, and then number of reviews, last reviews, and a lot of things are there, a lot of columns are there. So we're going to analyze each and everything in Python, and let's first go ahead and create a Python file, then we're going to import this data sets. Okay, let me just close it and let's create a Python Jupyter notebook file. So I would just right click on new file. I'm just going to call it day23.ipynb. You can name whatever you want. So this is fine. Let's kind of add a new markdown and let's add a comments call listing 2024. Okay, so this is for new work, so let me just add new work. Okay, so in this project we're going to follow a step-by-step approach. So let me just write down the step-by-step approach that we're going to follow to complete this projects. So I would just say steps. Let's see steps, and first steps is going to be obviously importing all the dependencies, all the libraries, right? So it's going to be importing all dependencies, which you can also call libraries. Okay, that's the first. Second is going to be obviously the loading the data sets. Okay, then we're going to do explorations of the data, which is the initial explorations. We'll explore the data, like what is the number of rows, what is the number of columns, the data types, each and everything. Then in the fourth step, we're going to do a data cleaning to see if there is any duplicate records, to see if there's any null values. We're going to deal with those things. And in the fifth, we're going to do a data analysis, where we're going to use all the different libraries like Matplotlib, Seaborn, Pandas, Numpy, each and everything. Okay, so that is going to be the step-by-step approach for this project. Now let's go ahead and launch our terminal and let's install all the dependencies, all the libraries that we need for this project. First, you need to make sure that everything that we're doing in the same directory. So in this day 23, I want to keep this Jupyter notebook as well and the dataset as well. Now everything in the day 23. So if you want to verify it, I can just create one more folders here and I can move that into this my week 4, and you will see in the week 4 I have now two folders. One is something called ts, nothing inside that. In the day 23 I have these two files, so you need to make sure that both the files are in the same directory. Okay, so that is fine. Let's go ahead and see what are the dependencies, what are the libraries that we need. So for that we can just launch our terminal. So I'm just going to use a terminal and let's go ahead and install all the libraries that we need. So first of all, we need to work with the pandas. So I'm just going to say pip install pandas. If you have already installed pandas, so you can skip this. So that is first thing that I'm going to install pandas. So let's go ahead and install pandas. So you can see it is installing pandas, and I will also install Numpy. So I would say pip install Numpy. I think it has already installed Numpy. So by default, when you install pandas, it install Numpy as well. So Numpy is installed. Then I would also need Matplotlib and Seaborn. So I'm going to say pip install Seaborn and Matplotlib. Okay, these are the two libraries I need to install. So you don't have to add anything and sign or oblique sign here. So just run this and you will see that it is going to install successfully. So now it has installed Matplotlib and Seaborn. So these are the libraries that we need. We can verify the package by saying pip list and you will see the packages. So we have, which is all the important libraries. So let's kind of verify it. Okay, let's see for pandas, we will go to p and let's see pandas install, Numpy install, Let's check for Seaborn is installed. Let's check for Matplotlib, that's going to be in M. So Matplotlib inline install. So all the dependencies libraries are installed. So let's go ahead and import all the libraries. Okay. So we will write down a step-by-step approach. So that's going to be very helpful. Let's go ahead and import all the libraries. So first we will start with import pandas as PD. Then we're going to import numpy as np. We're going to import matplotlib dot pyplot as plt, and we're going to import Seaborn as SNS. Okay, and we will also need to import %matplotlib inline so that we can create matplotlib inside this Jupyter notebook. Okay, so these are the mandatory commands that's going to import all the dependencies inside this Jupyter notebook. So initially it will take a few seconds, so that is fine. You can see it took 6 seconds for me. Now everything is imported. Next task is going to be the task 2. So let's go ahead and write down as a task. Okay, here I'm going to mention as a task 1, and let's go ahead and say task 2 here. So task 2 is going to be loading the data set, which is here. Okay, so I would just go ahead and say here that task 2 and loading data sets. Let's kind of make it bold by double star, putting double star before and afters. So you can see loading data sets. Now we're going to import the data set. So we're going to load the data set using pandas data frame, which is read.csv, because it's a CSV file. Okay, so I'm just going to create a variable called data maybe, and data equals, and I would say pt dot read CSV. Now this is only going to work if you have imported pandas as a PD. Okay, otherwise you will not get this option. So pt.read CSV. Let's go ahead and import this file. So I would just copy this. I'm just going to add a line called encoding error equals ignore. Okay, so this is going to ensure that if any row has any issues, like where you see this CSV file, it works row by row, right? If any rows we have any issues, any problems, so that row is going to be ignored. Okay, so that is what we need to pass, encoding error as ignore, and let's kind of go ahead and run it. So import is successful. Now you can see that Panda has created data frame called data. Inside data it has imported. Now the data frame is imported. Let's go ahead and explore the data set. So I am just going to mention as a task 4. Okay, so let's go ahead and say task 3. Okay, and it's called initial explorations. Okay, we're going to explore the data here. Now let's go ahead and explore the data set. So first we will start with data.head to see the first 5 rows. Let me just hide everything else now. Now you can see here we have the first 5 rows of the data. So this is the first rows, and in the first rows you can see we have listing ID is the first column, and we have this some of the ID serial number. This is the property name. This is the host ID, so the person who is hosting this property on Airbnb. This is the host name. This is the neighborhood, which is basically the locality, and this is another neighborhood. This is the neighborhood main group, and this is the neighborhood maybe the subgroup. We have latitude and longitude, so the locations in the map using this latitude and longitude. We have room type, so this different room type we have, which is called private, maybe the entire home apartment private. So there would be different types, so we will explore that later on. We have something called price. We have last review per month, calculated listings count, availability. Okay, so it is important to explore the data before jumping to kind of doing anything in the project. So you need to know your data first, then only you can kind of solve the business problems. So we have license, so different license type for each of this property. We have bedrooms, which is important. In bedrooms you can say 1 bedroom, 2 bedroom, maybe more different options. We also have studio. We have bath, so here also you will have different types of bath. Okay, so this is the data set, and this is the head. If you want to see the last 5 rows, for that you can use something called tail. So we can go ahead and say here tail. So that is going to give us the last 5 rows from this data set. So you can see now we have the index, which is 20,765, and here you can see the host name, and rest of the information you can see same as it is. Okay, so this is how you see the data head and tail, the first and the last 5 rows, a quick glimpse of the data set. Okay, Let's now go ahead and see something called a shape to see how many numbers of rows we have and how many numbers of columns we have. Okay, so you can say data dot shape and you can just run this query and you can see it is showing the shape of the data, which shows that 20,770 rows we have at the moment and 22 columns we have. Okay, so this is the data shape. Let's go ahead and now see the data informations. So for that, where you would see each of the columns in their data types and number of not null values that each of this column has. So for that, you can say data dot info parenthesis to get the clean results. So here you can see you have all the columns and a lot of information. Let's go through one by one informations quickly. So here we have different columns name. You can see total 22 columns are there, and if you see the entries, we have 0 to 20,769 records. That means 20,769 records we have. Okay, but if you see ID for we have, which is not null values in this ID column, which is 20,770. Okay, so one record extra we have in ID. So basically it is including that the first column as well, which is the column name itself. Okay, if you see name 20,770. Okay, so this is the not null values we have in this ID column. Okay, but if you see something here, maybe in the neighborhood, you can see there are 20,763. That means 7 record is missing here because only we have 20,763 not null values. Okay, so we need to find out those 7 missing records. We will see later on. Now one more thing that you will see is the data types of each of these columns. So ID is a float data, which is a number data. Name is the object data, which is the text and data. Host ID is the number data, and host name is the object data. Okay, so you can see each of this different columns, their number of not null values that they contain and their data types, which you can see it from here. Okay, now next we're going to create a report, which is a statistical report of our data sets, all the number columns. Okay, so for that you can simply use a data dot describe. Okay, and this is going to kind of give you this is going to give you the statistical reports of your data of all the numbers column. Okay, so I'm just going to write maybe a line here called statistical summary. So let's explore this stats for a few of these columns which are important. So basically for price we want to see the count. So if you see the total count, that is called 20,736 records we have. That means there are some records which is missing. Okay, because we should have 20,770 but we have 20,736. Okay, maybe 30 plus records where price is missing. You can see it here, the count. Okay, now if you see the mean, which is the average, that is 187. So that means the average is 187 for each listing. This is the average price. If you see the standard deviation, that is here, you can see 1023. If you see the minimum price of listing, that is $10. If you see the 25% quartile, that is the $80. So $80 property falls into this 25% quartile. Then in 50% it falls $125, and rest of them falls in 75%, which is $199. Now if you see the max price, that is shows that the property has the maximum price, which is $100,000. Okay, same way if you see the minimum night, so the average is $28. If you see the standard deviation 33, and if you see the minimum night, that is one night, because one night could be the minimum, right? And if you see 25%, that is 30 night, and 50% 30 nights, 75% 30 nights. Okay, number of reviews, I can see the number of reviews and their statistical measures. Review per month, their statistical measures. So all the number columns, and you can see their statistical measures here. Okay, so the most important one is the price, and maybe you can go through this one, which is called bed. So here you can see different bed and their statistical measures. Okay, so this is how you can create the statistical summary of your data sets. Okay, now that was our task 3. In the task 4, we are going to do a data cleaning. So I am going to create a markdown here. I'm going to say task 4, and task 4 we will be doing data cleaning. Okay, so first let's identify each of the columns and number of missing informations we have, missing values in each of these columns. Okay, so for that you can say data dot is null. Okay, then you can add a parenthesis and you can add a sum to see how many missing values we have in each of these different columns. Okay, in ID there is no missing values, name there is no missing values, but if you see neighborhood, we have 7 missing values. In latitude we have 7 missing values. So seems like in all these 4 columns we have 7 missing values, but if you see in price we have 34 missing values, and rest of the column 7 missing values we have. Okay, so you have now two options. One is you can replace those missing values with something like maybe average, mean, or mode, or you can kind of drop that entire rows wherever you have missing values. Okay, so here for us we're going to drop the entire rows and we're going to update this data frame which is called data. Okay, so that is what we are going to do using drop now. Okay, so for that you can just say data dot drop now, and then you can just add a line called in place equals true. Okay, so this is going to drop this missing values, and if in case you want to kind of, let's add a line called dropping all missing values rows. Okay, so any rows that has a missing values, that entire row is going to be deleted here using this drop now. If you want to replace that with something, so you can use that which is called fill now. Okay, so you can use a fill now, and that's going to fill all those missing values. You can say data dot fill now, and you can put whatever you want to basically replace with. Okay, so I'm just going to comment it out because I'm going to use drop now. Okay, so after dropping I just want to print the missing values again, so I'm just going to put it here, and let's kind of see. If you see now there is no missing values, all the missing values are gone because the record has decreased now. So now if I go ahead and show you the shape, so the data of shape is going to be, you can see now the shape is showing 20,736.22. Earlier if you see the shape which is before dropping those missing values records, it was 20,770. Now it is 20,022. Okay, so that means few of the records has been deleted, maybe 35 or something record, 34 record has been deleted. Okay, so this confirm that we have dealt with the missing values records. Now let's go ahead and see if in case our data set has any duplicate records. Okay, so for that you can go ahead and say data dot duplicate it, and you can simply run this, and you can say sum. Okay, so it is going to tell the total number of duplicates that you have, which is, you can see 12. So we have 12 number of records where the entire row is duplicate. Okay, even if you want to see the entire duplicates, so we can go ahead and let's just add a comment call dealing with duplicates rows. Okay, now if you want to see the duplicate records, so for that I can say data dot duplicate it, and you just need to put this as a filter, and you can just run this query. So all this record that you see, these are duplicate records. Okay, so here you can see the duplicate records is the 12 duplicate records. Okay, so very simple approach, because this returns a boolean which is true and false. If it is a duplicate, it's going to return as a true, otherwise it's going to return as a false. Then you can put that in this data as a filter. Okay, this is how you kind of see all the duplicate records from your data sets. Now we want to delete all the duplicate records, so for that you can just go ahead and say that add a comment called deleting all duplicated rows or records. So entire row is going to be deleted if that row is a duplicate. So you can say data. So to do that, what you can do, just let me just comment it out, and we just need to say data dot drop of duplicates. Okay, now we would just need to again use in place, because we want to implement in the actual data from which is called data. So we would say in place equals true. Okay, now if I just show you the total number of duplicates after deleting it, so I can just put this after this line, and that is going to show the number of duplicates. Now you can see 0. Okay, so even if you want to see this query which earlier returned all the duplicate rows, you would see it is going to return null at the moment, because we have already removed all the duplicates. You can see now there is no duplicates, a 0 row that it has returned at the moment. Okay, so this confirm that all the duplicates is removed from our data frame which is called data. Okay, that is where our data cleaning ends. Now you can also deal with the data inconsistencies, like you can deal with the data types formatting as well, if in case your data is not formatted properly. For that you can say that data dot d types. Okay, so here you can see that all the columns in their respective data types. If you see any columns and the column is not in the correct data types, so you can change their data types. Okay, for example, if you see ID, it is showing as a float. For name it is showing object, for host ID it is showing as an int. Okay, so this to ID and this host ID, okay, we can change it to kind of object instead of showing it as a float. Okay, because this is not that much important. So the way you can change it is very simple. You can just go ahead and say that data of this ID, okay, dot s type, and you just need to give your type what you want to change. So we want to change as a object. Now we just need to implement into this actual data frame of this ID column. So for that, what you can do is that you can go ahead and say that data of this ID, okay, let's update it, data of this ID equals, okay, this which is going to be again that data of ID. Okay, so this is going to kind of update this data types to object. Okay, now I can just verify it. Let me just run it after this, and you will see this time this ID, the data type has a chance to object, because the reason we have changed this ID because it's kind of ID, so there is no sense of keeping it as a int, because in int we want to keep something like where it is price, number of bookings, or something where we can do sum, right? There is no way we can do sum in ID, right? That makes no sense. Okay, so same way, this is one of the way to kind of deal with changing the different data types. Okay, we can just say that this is called typecasting. Okay, you can say changing data types. Okay, so we have done for ID, we can also do for this host ID as well. So for that we can just do the same thing here. Let me just go ahead and say host ID this time. So I want to replace the host ID and host ID here. So I want to change it with again the same, which is called the object. So now host ID also the type has changed to object. Okay, so this is fine. Next, if you see latitude, longitude, I want to keep it as a float. Room type, that is object, fine. Price is float, which is very important, that is also fine. Okay, I think rest of the columns are perfectly in the correct data format, so we don't have to do anything else here. Okay, so that is perfectly fine. Now this was our task 4. Let's go ahead and do our task 5, which is going to be data analysis. Okay, so let's go ahead and write task 5 here. Task 5, and we would just write data analysis. Okay, so let's first go ahead and see univariate analysis. So, and let's write it down as we're going to do now EDA, which is part of data analysis. So we would say EDA, put this on the first. Okay, so in the EDA we're going to do data analysis, and we're going to do univariate analysis. Now if you do not know what is univariate analysis, in simple term, univariate analysis is analyzing each of the single variables, like single columns and their data distributions. Okay, so for example, you want to see how the price are spreaded in the across the data sets. Basically you want to analyze the data distributions of each of these single columns. That comes into the univariate analysis. Then we're going to do bivariate analysis, where we are going to compare effect of one columns in another columns, which is effect of one variables in another variables. So let's first do univariate analysis. In univariate analysis we will analyze maybe the price columns. Okay, so let me just run it, and let's go ahead and first analyze the price. Okay, price distributions. Now we want to analyze the price spreaded in the across the data frames. So for that, let's go ahead and see the price, right? So you can say data of price, and you will see that the price, which is, you can see each of the records, they have a different price, right? We have already seen min and max earlier, right? So using the describe options, we have seen the min and max for the price. So this was the min, and if you see this is the standard deviation, this is the minimum price, this is the maximum price is this. Okay, so I've already seen. So let's kind of create a histogram to see how the price are spreaded in the across data frame. So for that, what you can do is that we can go ahead and here, which is called sns.hisplot, and we would say data of data, because our data frame name is data. Here we just need to give the x values. We want to analyze the price. Okay, so we would say price. Okay, bin size, we can keep it maybe later on I can just check the bin size. For now, let's just keep it default. Let's kind of run it, and it's going to create a histogram, and it's going to spread the price. Okay, So you can see here is that we can see the chart, but it's kind of very hard to analyze it because there could be some outliers. There could be some price that we have at this segment, which is $100,000, but most of the price are in this segment. Okay, so we need to now identify if there is any outliers we have, like if there are few price are here and most of the price we can see it here. So we need to kind of ignore all those price that is maybe greater than maybe 1,000 or 2,000. Okay, so for that, let's go ahead and see the outliers. So for that, we will just go ahead and add one more cell here called identifying outliers in price. Okay, so we will just go ahead and say sns.boxplot. So boxplot is used for identifying outliers. So you can say sns.boxplot data equals data for us, and we just need to say x. So x equals what you want to see the price. Okay, you can give it x or y, that's totally fine. Okay, so let's kind of run it. Now you can see most of the price, if you see this box plots, so most of the price that are kind of spreading between 0 to maybe somewhere around less than 2,000, right, maybe $1,500, and there are only one price or maybe one or two few, just very few prices are here which is at this 100,000. Okay, which is causing the issue. So we need to kind of deal with these outliers. Either we want to remove these records where we have the price which is greater than kind of maybe 1,500. Okay, that is what we can do to deal with these outliers, because we need to remove this outlier to analyze this data. Okay, for that we can do a simple steps here to do that. Okay, so we will just go ahead and create a new data frame maybe here. Okay, so I would just go and say df is the data frame that I'm going to create, and I'm just going to use this data of price as a filter. So I would say price, and I would say the price must be less than maybe 1,500. Okay, so this is what I want to call it. This is going to give me a boolean true and false. I would just kind of filter it from the data frame which is called data. Okay, and I'm going to save this inside this data frame. Okay, so that is what I'm going to do. Now let me just run it. It has already created a new data frame, and we can use this data frame this time in boxplot to see if there's any other outliers we have. Okay, so that's going to replace it here, and let's kind of see. Now if you see, there are the maximum price that are relying between this and this, so there is no outliers. Okay, at the moment, I mean, there are less chance of getting outliers because you see they are uniform distributions, so the price are spread equally between this range. Okay, earlier we had some price here and some price here. Okay, so this is perfect. Now we can kind of change this data to df because we have created new data frames by removing the outliers or records. Okay, if you now run this query, you can see a nice kind of histograms which is showing here. Let's kind of give some name, and let's kind of shape this size. Okay, for that we can use some matplot functions which I have covered yesterday. So you can say plt dot figure is used for kind of giving different size. So you just need to say fixed size, and you can say fixed size, maybe I want something called 8 and maybe 5. Okay, so this is fine. And next, what I want to give some title for this count. I want to give the frequency instead of count, so that's going to be my y label. So I would say plt dot y label, and I can just name it called frequency. Okay, frequency. So this kind of fine. Let's run it. You can see it showing the frequency, the price distributions, and this is the price. Okay, so if you see the different listings, so most of the listings are spreading between maybe $10 to kind of this $400, and after $400 there are very few properties that we have. Okay, so this is how you can see the distributions. You can change the bin size now as well. So you can say bins to different bin size, maybe 100. Okay, and you can see the clearly the data. So bins are basically this distribution frequency that you see the bins. Okay, so here you can see nice clear chart that tells the price distributions. Okay, so most of the price are, you can see, between maybe this 10 to this $400. After $400, the properties, number of properties are basically reducing here. Okay, so this is how we have dealt with outliers, and we have analyzed the price distributions. Okay, so this was part of univariate analysis, which is a single variable analysis, and the data distributions. Let's go ahead and analyze some more data. So we would want to see all the columns. So we would say data of columns. Let's see all the different columns we have. So data of columns, So we have all these different columns. Now you can analyze the data distributions for each of these columns, or you can kind of analyze whatever the columns you feel important. So we can analyze it maybe for something like any other number column. So I would just go ahead and say data dot d types. So here, if you see here, we can analyze different columns and their data distributions. So you can only analyze this number columns. Okay, for the number columns you can create the histograms and you can see how the data are spreaded. Okay, so maybe we can do for a room type, that's object data type we have done. For the price, minimum night, not too many options, so that's again not the right columns. Last review per month, so this is something you can analyze, that's on you. And you can analyze for this availability of 365. Okay, so how many days each of these properties are available, so that one we want to analyze using histogram. Okay, for that I'm just going to copy everything, and again let me just add some more thing here called plt dot show to remove all this text. Okay, and let's add a title here. So we will just add a title called plt. Title will come after the figure. So before the y label I am going to add a title called plt dot title, and here I'm going to add a title called price distribution. Okay, you can see nice title now, price distributions, frequency, and the price. Okay, so this is fine. The same way we want to now kind of analyze it for next column, which is going to be this availability. Okay, so let's say price, availability, distributions, and price, I would change it to availability. Remaining everything same, works same, I would just change it to 6 and maybe a kind of 3. Okay, bin size we need to check. So bin size, I think I just need to remove it to see the automatic bin size. Okay, this kind of perfect. So if you see here kind of the availability, most of the property that you see the availability, they falls between this and this. A few property has kind of ununiform availability that you can see. Okay, so this was the availability of 365 and their distributions, that columns and their distributions. Okay, you can do for the rest of the columns. Okay, now you can use a for loop to create multiple histogram in one go as well. So I will not go into that deep, but you can analyze by yourself. You can, maybe you will be getting some other insight. Okay, now let's analyze the data sets using simple group by before creating bivariate analysis. So I would just go ahead and say data dot, it's called d types, to see all the data columns and their data types. Okay, here we can analyze the neighborhood, which is the locality, and maybe we want to see the average price. So in each neighborhood, what is the average price we have. Okay, so for that we can simply use a pandas data frame, which is called group by. So data frame, which is called df, is our the name. Okay, then we would want to just do group by, data frame of group by, and here we would just need to say by which columns, the columns that I want to do a group by this column, which is called neighborhood group. Okay, and what I want for from this group by is kind of, what I'm looking for is kind of maybe mean, and mean on which column. So I just need to put that column here. Okay, so the column is going to be the price. Okay, price column, I'm just looking for mean. So if you see in each of this neighborhood and the average price. Okay, so now you can see each of this neighborhood and their average price. For Bronx, this is the average price. For Brooklyn, this is the average price. For Manhattan, this is the average price. For Queens, this is the average price. Okay, so each of this locality, and you can see their average price. Okay, now we can do some feature engineering, as we have the price, and if you see the head of the data, so we can just go ahead and say df dot head, and you will see that we have something called a bed. Okay, like how many beds. Okay, so the price that you see here, that has something called, so if you see the price, here is the price $55, and if you see the number of bed is 1, and here if you see number of bed is 2, the price is 187, right? So what you can do, we can create a new feature which is called new columns, which basically gives us a per bed a price. Okay, so for that we just need to divide this price by this number of beds we have, and then we need to basically save as a new columns. Okay, that is what we're going to do. So that is going to be part of our feature engineering. Okay, so let's go ahead and create a new columns which basically return as price per bed. Okay, then we are going to do again this group by price per bed. Okay, so for that what I can do is that we can go ahead and create a new columns. Okay, to create a new column, let me just comment it out, and we can say df of what, which is called price, divided by df of which is called bed. Okay, so this is going to create a data series, and that we want to kind of store it in the data frame. Okay, for that I am just going to create a variable, and I would just store it df of new columns. Okay, to create a new columns I can simply use this df of this. So let me just go ahead and put it here. Okay, now I'm creating a new column df of this price per bed, and I'm assigning these things. Okay, if you see this kind of divide simple price times bed. Okay, very simple approach. Okay, so let's go ahead and kind of print the head now. After this, now if you see, it has created a new column which is price per bed. Okay, so here if you see 55, maybe the price is 55 and this bed is 1. If you see 2 bed, so here if you see it was 187, now the price per bed is 93. Okay, now we can do a group by this columns instead of simply putting the price here. So let's go ahead and add a new code here, and let me just kind of put this. Okay, so let's kind of go ahead and use this price per bed. Okay, instead of simply using the price. Okay, now if you see the difference, Bronx, for Bronx it's $74, it was earlier 107. So this is price per bed. Okay, if you see Brooklyn 155, Manhattan 204, and Queens 121, 118, and if you see here Brooklyn 99, Manhattan 138. Okay, so there is a huge difference price per bed. Okay, compared to the each neighborhood and the price. Okay, average price. Alright, so this is where we can see the average price per bed. Price per bed. Okay. Alright, now let's go ahead and do a bivariate analysis. So let me just add a comments, and let's say bivariate analysis. Let's kind of make it bold. Now bivariate is same as like a univariate. In bivariate you will be analyzing one column with another columns. Okay, so we will analyze one column relationship with another columns. Okay, how one column is dependent in another columns. Okay, so we will be analyzing one variable dependency in another variable. In simple terms we can say how one columns affect another columns. Okay, so that is fine. Let's go ahead and do some bivariate analysis now. Let's kind of add a new cell which is called df dot columns to see all the columns, and then we will build our logic. Okay, so let's first go ahead and see how the price is dependent on the neighborhood. Okay, so for that we can simply go ahead and say that sns dot bar plot, and we would say data equals df. We want to see how the price is dependent on the neighborhood. So x is going to be our neighborhood, which is called here this one, which is called neighborhood group. Okay, that's going to be our x. Then we want to see the price. Okay, that's going to be our y. So y equals price. You can also do the price per kind of columns as well, price per bed as well, so that's totally fine. Let's go ahead and run it. So here if you see the neighborhood and the price dependencies. Okay, so in Brooklyn this is the price, in Manhattan this is the price, in the Queens this is the price. Okay, so we can just add some colors. So for that I can say hue equals by maybe room type. Okay, we have some room types, so based on the different room types you can see the price in different neighborhood. Okay, so private room types, if you see in Brooklyn this is the private room type price, which is under $100. If you see in Manhattan this is kind of $150 for the same room type. Okay, so if you see hotel rooms, for hotel rooms in Brooklyn it is kind of somewhere around 160 or 70, and in Queens, so different cities, and you can see different data distributions here. Okay, so this is how you can analyze one variable dependencies on another variable. So here you can see the price is totally dependent on this neighborhood. Okay, some neighborhood has the highest price, some neighborhood has a lower price, like city like Manhattan, which is a big city, so here you can see the price is higher, and same way some other cities where you can see the price is lesser for the same type of rooms, like you can compare it with this private rooms. Okay, so this one I'm just going to add a nice text which is called price dependencies on neighborhood. Okay, that's fine. Now let's go ahead and analyze maybe number of reviews and maybe with price. Okay, let's see if there is any relationship we have number of reviews with a price. Okay, for that I'm going to create a scatter plot. So let's say number of reviews and price relationship. Okay, so for that I would just create a scatter plot. So I would say sns dot scatter plot. Okay, and here I would say data equals df, of course, and in scatter plots I am going to kind of say my x, that is going to be maybe something called number of reviews, or maybe I can use the price, anything is fine. So I would just use maybe the price, maybe number of reviews. Okay, so that's fine. And in y I would use the price. Okay, so let's create a scatter plots, and we can kind of give some colors here. So I would just go ahead and say hue, and we can do a color by type, or we can give the color by locality. Okay, so that's going to be perfect. So here we can give different colors based on this neighborhood group. Okay, let's go ahead and run it. So now you can see here is that we have number of reviews and the price. Okay, so if you see the price is higher, the chances of giving a reviews is kind of less. Okay, so let me just make some adjustment with this plot. So let's just make, say, plt dot figure, let's increase the size. Okay, so I would say fixed size, let's kind of give it 10 to 8. Okay, so maybe I want 8 to kind of 5. Okay, so this is fine. And here if you see the hotel which has the highest price, for those hotels we are getting less reviews. Okay, so this side is the reviews and this side is the price. Okay, but if you see somewhere where the most of the reviews that we are getting, that is for this range. Okay, where the price is maybe somewhere around $600 less than maybe $10. Okay, here the price is very less, maybe $10 to $200. Most of the reviews we're receiving here. You also have different kind of neighborhood. Based on the neighborhood you can see which neighborhood we are getting highest reviews. I think Brooklyn, for Brooklyn, and maybe this orange color, that is for Manhattan. So these are the two neighborhood where we are having the maximum number of reviews. Okay, so this is what we can analyze. Now we can add a title here. We can just say plt dot title, and we can say here is called locality and review dependency. Okay, you can give any name, that's on you. Okay, so we can just hide this plt dot show. So y label and x label is already given, so we don't have to give. Okay, so this is a perfect of kind of showing how the price and reviews are related with each other. Okay, now this is fine. Let's go ahead and create one more plot, which is going to be pair plot. So we want to create plot for all possible number columns. Okay, for that let's go ahead and say df dot d types, and we can see each of the columns and their data types. So we want to create a pair plot for all the important number columns. Okay, we want to see the different possible kind of combinations with each others. Okay, so for that we would just use this all the number columns. Okay, wherever the columns, number columns, and we want to see their relationship with each other. Okay, so for that we can say sns dot pair plot, and here we want to simply give the all the number columns. So let's see what are the things we need in the pair plots. If you just write a question mark, so we just have all these different options in bars. So here if you see in pair plots, we will need to give different parameters. So first is the data, then we have hue to basically give different groups, different colors. Then we have, which is bars. Here it is list of variable names with data to use. Otherwise use every columns with a numerical data types. Otherwise it's going to by default create all the columns and combinations. So each columns and their relationship, it is going to create different charts. We can put our the number of columns here manually as a list or as a tuples. Okay, so this is what we're going to do. Let's go ahead and kind of first give data, which is going to be df for us, and then in vars we are going to give all the different columns that we want to create a pair plots. Okay, so pair plot is going to create different plots in different axes. Okay, so we want to see maybe from here something like maybe latitude, longitude. I don't want room type, it's not important. We want to include this price columns, that's our first number columns. And let's see if there's any other columns. Number of nights, yes, we want to see number of nights. So then we want to see number of reviews is a float. Yeah, we can say number of reviews as well. And dependencies, last reviews not important, last reviews review per month not that important. So calculated host listing count, availability, yes, we want to include this availability as well. So I think I'm going to include this four columns. Let's see if there is any other important columns. We have license, number of rating is object. I don't want bad is not important. So yeah, I think these are the columns that I want to kind of create a pair plots. I'm going to just add a hue here to add a color effect based on different maybe bed types. Okay, so for that room types, for the different room types, I want to have a different colors. Okay, so let's see the pair plot. It is going to take some time to create this pair plot because it is going to go through entire data frame and then it is going to create the pair plot for you. So here if you see the pair plot, so it has kind of created four combinations. So this price, we are seeing this price relationship with minimum night, price relationship with number of reviews, price relationship with the availability. Okay, and so this is what you can see here. Now you can see it has created the pair plot. Let me just make it little smaller so that you can kind of understand. So you can see price, minimum night, number of reviews, and availability. So same way, availability, number of reviews, minimum night, and price. Okay, so price with price, that means this is price with price, this one is price with minimum night. So if you want to understand, this is a scatter plot. It has created price with minimum night. So you can see where the price is higher, and you can see the minimum night is kind of that it's showing the data distributions, the price and minimum night. Okay, so most of the room type that you see, which is called entire home, that you can see it here. Okay, same way this is for price with number of reviews, and if you see the price is higher, so the number of reviews are less, where the price is less, number of reviews are higher, which you have already seen. And entire home, we have received maximum reviews. So this one is the last one, availability, and you can see here for the availability, which is from here to here, which is 0 to 400, and based on the price, and you can see different relations. So you can spend some time to understand the relationship with each of this plot. It is really easy to kind of identify the relationship in a pair plot because you can visualize all the possible chart here. Okay, now let me just go ahead and show you how to create a geospatial chart to analyze the data based on geographical locations. Okay, because we have longitude and latitude, so these two columns I can use to create a scatter plots. So here I would just go ahead and say that what I want, geographical distributions, Airbnb listings. Okay, so let's first go ahead and kind of create a kind of scatter plot. So I would say sns dot scatter plot, and here data is going to be my df, then my x is going to be maybe the longitude, and my y is going to be latitude. Okay, so latitude, and hue is going to be, we want to analyze maybe based on the different room types, so we can analyze based on the room type or anything that you want. Okay, so this room type has kind of less options, so it's kind of going to put the nice colors. Okay, so in each of these locations we will be able to see. Okay, I would just go ahead and now run this. It's going to create the geographical location. There is some typo, let's kind of go ahead and replace this latitude here and replace this longitude. Yeah, this is kind of fine. Yeah, it's a longitude. Okay, so you can see it has kind of created a chart. So let me just make it little big. So I would say plt dot figure, and let's say what I want is the fixed size, what I want maybe 10 and 8. Okay, 10 and 7. much better. Again, you can increase it more if you want, but much better we can still analyze it here. Okay, so if you see different room type, we have given different colors, and this is the longitude, this is the latitude. So if you see, most of the properties are located between this longitude and this latitude, so in this portion. Okay, so that is from 74 to 74 to kind of maybe 72 longitude, and if you see the latitude, so that's kind of 40 to maybe 49. Okay, and if you see here, like in this portion, so most of the entire home apartment are located. So the property types, if you see here in this sections, it is more of like private rooms, and if you see in these sections, more of like private rooms. So I think these hotel rooms are very less in this only this sections. I can see few of the listing. Maybe we have very less kind of listing in New York, which is kind of hotel rooms. Okay, but compared to private rooms and the other, the property type, that is more. Okay, so you can see now each of these locations geographically and how the data is distributed. We can just add some nice name using plt dot title here. So I would say plt dot title. Let's go ahead and put some string here. It kind of add a nice name, and let's remove this text called plt dot show. Okay, so this kind of perfectly it has created this chart. Now lastly, I just want to create one more chart to understand the correlation between one column with another. That is only for the numerical columns. Okay, so let's go ahead and say that df dot d types once again to see all the columns, and then we're going to create kind of the correlation heat map chart. Okay, so if you see all these numeric number columns that we're going to use in the correlation. Okay, let's kind of go ahead and say that we want to create a heat map chart variable with others for numerical column. Okay, the way you can create heat map is that first of all you need to identify, you need to create a subset of all the number columns. Okay, because correlation only works on the number columns, you cannot create a correlation on non-number columns. So we can create a variable called core, and in core we can kind of assign all the columns that are number columns. Okay, so for that, what I can just go ahead and say that all the number columns I can just copy one by one here. So that's going to be maybe latitude for me, first column. Then it's going to be maybe longitude, that's my second column. Then maybe it is going to be something like, after this I may want the price. Okay, then I would want this minimum night. So let's see if any columns I need. Number of reviews, yes, I need these columns as well, number of reviews, and I may need review per month as well. I would just go ahead and include it, review per month. And I would need this, which is availability. Okay, so I think this is the columns which I only want. Okay, in this correlations, in this heat map, again you can include as many as columns. We can include also this bedrooms. Okay, this one beds. Okay, so let's see if the bed has any relationship with the price. Okay, now we will just go ahead and kind of say that we need this subset from where, which is called from the df. Okay, so we need this subset from df, and we are just going to say core to kind of create a correlation matrix. Now if you just want to see this core, I can just show you. It's going to create a kind of matrix which kind of show each of these columns and their correlation with each other. So you see all the columns name here as well, here as well. So latitude, you can see with latitude it has a positive correlation, which is perfect positive correlation, which is 1. So correlation value will always remain between -1 to +1. Okay, so +1 is perfectly positive correlation, and -1 means perfectly negative correlations. Let's see if I talk about price and maybe something with number of reviews. Okay, so if it is kind of 1, if the price increase, the number of reviews increase, the relationship is going to be 1 or positive numbers. If basically there is no correlations, it's going to be 0. But if it is going to be like the opposite, that means if the price increase, the number of reviews decrease, so it is going to be negative in the correlations mark. Okay, numbers. Okay, we will see that. So now here you can see a matrix. Now we can just plot this in a heat map to kind of see this correlation. So for that you can say just say sns dot heat map, and here you just need to give some of the parameters which are important. Okay, so we can just go ahead and say that data is going to be our this, which is correlations And here next what I need to just give something called n not equals true to see the values in the each of this plot. Okay, in each of this axis I can just run it. You can see it has already created a correlations. Let's kind of give it a nice figure which is called plt dot figure size fig size. Let's give it maybe something called 10, something called maybe 8 and 8. Okay, 8 and maybe 10 I want to give it. Maybe I want to give it called 8 and 6. Okay, this kind of perfectly fine to analyze it. So let's kind of explore it and let's try to understand from here. Okay, so if you see latitude with itself, so this side we have all the columns, this side also we have the same columns, and if you see the correlations that start from here, which is -1 goes up to 1. Okay, if it is 1 it is a perfectly positive correlation. If it is -1 it is a perfectly negative correlation. If it is kind of 0, that means there is no relationship between each of these columns. Okay, let's first of all see maybe something with price. Okay, I want to see the price with a number of reviews, if there's any correlations. Okay, or maybe the price with bad, we can see price with bad. Okay, because if the bad number is more, the price would be more, right? That's kind of really, I mean, that's possible, right? So we can see the price. This is the price columns. So in this columns you see only for the price and other columns. So we need to say price and the bets, which is going to be this one. Okay, now can you see this is kind of highlighted in red colors? So this shows that this price has a perfectly positive correlation. That means if this price increase, the number of bet also increase, or you can say if this number of bet increase, the price also increase. That's where you see this is showing in the red colors and it's a positive number. Okay, now if you want to see the price and maybe the negative correlation, that would be price with something called longitude. I'm not sure why, but maybe that's one of the reason. And next, if you want to see like maybe more negative, it's kind of -1. You can see price with something called minimum night, because again the price and minimum night has no relationship. So that's the reason you can see it is showing in minus. Okay, now again I will suggest you to spend more and more time to understand the correlationship between each of the variables, which is numerical variables. This is very important concept, and once this concept is clear, you can create any charts that I have covered in the earlier sections. Now you can spend more time and analyze this data set, create different charts, and try to find out your insight from this data set, which you can note it down and write it down, all those insight into a PPT. You can create a PPT and kind of submit as a report in the project, right? So that is what the main goal is. That's it for this video. I hope you have learned something new today. If yes, do hit that like button, share your thought in the comment box, and do subscribe to my YouTube channel. I will see you in the next video. Till then, keep learning and stay consistent. Have a good day. Take care. Bye bye.